Hi, you guys. This is Mrs. Bolin with your notes for 10.2 Subtracting Polynomials. We'll go ahead and get started with the warm-up, which is just kind of a review of what we did yesterday. So first of all, we are going to add like terms. So if I have 5y and negative 2y, remember positives and negatives cancel each other out. So I have 5 positives, 2 negatives. I've got 3 positive y's left. Okay, then I want to look for the next thing that's alike. So I have 4 positives and 6 positives. So altogether, that is 10 positives. So 3y plus 10 is your final answer. Remember, when we did distribution, if there is a negative out here, you can consider that to be a -1 when you're multiplying out. So if I'm going to distribute the -1 to both of those things, I get negative x or -1x. And then here's where we need to be careful. A negative times a negative is a positive 7. So that would be my final answer. So if you notice, the negative outside just changed the two values that were on the inside, the sign. So this was a positive x, now it's a negative x. This was a -7, now it's a positive 7. So we kind of just do the opposite of what we have in the parentheses. Just to review all the way back to Unit 1, if I've got 11 negatives and 12 negatives all together, that is -23. So think about if I have a number and I subtract 11 and then I subtract 12 more, I'm taking away 23. All right, question number 4. We're going to do another one of those distributing a negative. So remember, it just changes the sign of everything inside. So if I had a positive 4x squared, now I have a negative 4x squared. If I have a positive 3x, now I have a negative 3x. If I have a -5, now I have a positive 5. So subtracting a negative is the same thing as adding. Whenever we distribute that negative, it just changes the sign of everything on the inside of the parentheses that follow. Okay, so that's going to be important for today's lesson. All right, so our notes for today, same thing as what we did yesterday, with the exception of distributing a negative to the terms that follow. Okay, it's like multiplying by a -1. We're just flipping all the signs that follow it. Okay, then we're going to follow the same patterns that we did in the previous lesson in 10.1. Okay, so you guys ready? So the first step is always to distribute the negative. Okay, you can think about it like multiplying by a -1. You can think about it like just flipping the signs, doing the opposite sign of what's in there. So we start by copying the first one. So 6x plus 9 doesn't change. We can take the parentheses off, that's fine. We're going to distribute the negative or do the opposite of what's in here, okay? So subtracting a positive 7 is kind of like adding a -7. Or you can just say a negative times a positive is a negative, and then a negative times a positive is a negative. Okay, I didn't change the value of the number, I just changed the sign of it. Okay, so now we're going to put like terms together. So I'm going to say, well, 6x and take away 7x. Remember, positives and negatives cancel each other out. So if I have 7 negatives and only 6 positives, there's more negatives and there's 1 extra. So this would be a negative x. And then if I look at my constants, so I've got a +9 and a take away 1, that would leave me with a +8. So you just go 9 minus 1 is 8. Okay, but we need to make sure that we keep the sign of whatever there's more of. Okay, so this would be our answer in standard form. Okay, so we're going to go ahead and start the next one. Remember, our first step before we do anything is to apply that negative to everything that follows. Okay, so I'm going to just copy this first one. Y squared minus 4y plus 9. And then I've got minus 3y squared. Then I've got a negative times a negative is a positive 6y. And a negative times a negative is a positive 9. Okay, and then note here, the negative times a positive was a -3y squared. So now we're ready to combine our like terms. I'm going to start with the highest exponent on both of those. So I have 1y squared, and I have negative 3y squareds. Well, there's 2 extra negatives. Or you can think if I have 1 and I take away 3, I'm short by 2. So negative 2y squared. Then we're going to go to the next highest exponent, which would be the negative 4y and the positive 6y. So that leaves us with positive 2y. And then we've got positive 9 and positive 9. I know I kind of wrote on top of that. It's hard to see. But 9 and 9 is 18, so plus 18. And that is our final answer. Okay. Question number 3. Remember our first step. Copy the first one, so g minus 4. Then that negative gets distributed. So we have negative 3g, and a negative times a negative is a positive 6. Okay, so we keep the numbers and letters and everything the same. The only thing that changes is the signs. Okay, so now we're going to put together our like terms. I have 1g, and I'm taking away 3 of them. So again, I'm going to be short by 2, so 2g. And then I'm going to look to the next thing, which I have negative 4 and positive 6. The signs are opposite, so they cancel each other out. 4 of them would, but I'd still have 2 little pluses extra. So I'm going to write a plus 2 at the end. So after everything's done canceling each other out, I would still have 2 positives. So just ask yourself, what do I have more of, positives or negatives, and by how many? Okay, number 4. Our first step, remember, is copy the first one. Negative 5h minus 2. We distribute the negative. So negative 7h and then negative 6. So now we're going to put together our like terms. We're going to start with our letters, negative 5h and negative 7. If the signs are the same, there's nothing to cancel. So think about, I'm taking away 5 and then I'm taking away 7 more. All together, how much did I go down by? I dropped by 12 h's, so negative 12h. Then our next thing we're going to do is put this negative 2 with this negative 6. Same thing. If I lost $2 and then I lost 6 more, altogether I lost $8. Okay, those don't cancel each other out. They just add to make more of the same. All right, next problems. These ones are going to get a little bit longer. So we're going to distribute that there. So I have negative x squared minus 5. The first one does not change. We just copy that down because there's nothing in front of it, okay? This is attached to everything that follows. So that's why we're going to do the opposite. So minus a negative is a plus 3x squared. Then we have a plus x because negative times negative. Then we've got a plus 8 because minus a negative. Now we're going to put together like terms. So I'm going to start with the highest exponent. So I've got 3x squareds and I'm taking away one of them, which leaves me with 2x squareds. Then we're going to look for the next highest x with the exponent, which would just be our plain x this time. Okay, any other x's besides that one? Nope, so that one just kind of hangs out by itself. So we write plus x. And then at the very end, we would look at our constants. We've got a negative 5 and a positive 8. They're called constants because they don't have a variable. A variable is something that can change based on its value that we plug in, whereas a constant, 8, will always just be 8. Okay, so I've got 8 take away 5, which is 3. It is a positive, so make sure you write a plus there to separate those terms. Okay, so that is our final answer on that one. Last problem here for the practice, and then we'll go ahead and go on to the homework problems. Okay, so our first step is we copy the first one, k squared plus 6k cubed minus 4, and then we distribute that negative. So we have negative 5k cubed. Negative times a positive is a negative 7k. A negative times a negative is a positive 3k squared. All right, we've got some work ahead of us. First, we're going to start with the highest exponent. So I'm going to look at all of those and I'm going to say, well, I've got some k to the third power. So I'm going to start with that. There's 1, and that's a positive 1. I know it's kind of hard to see where I kind of colored over it. Okay, so if I have 6 positives and I have 5 negatives, 5 of those are going to cancel out and I'm going to have 1 positive left over. So I've got a positive k to the third. Then I'm going to look at k squared. So I've got 1 here and 3 more here. So altogether I have 4k squareds. Then I'm going to look for the next thing, which would be this minus 7k. And there's only one of them that just has a plain old k, so we just copy it. So minus 7k. And then if I look and see, well, what's left after I've done all of that? Just that little minus 4 right there. So I'm just going to write that at the end, minus 4. So that is our last problem in the practice. We're going to go ahead and do the homework together. So just the odd problems though, because you need to try something too to make sure that you're understanding it. Okay. And remember, you can pause me at any time. You can fast forward me if I'm going too slow. All right. That's the beauty of YouTube, right? In class, you just have to listen to me talking at normal speed, like womp, 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 womp. All right. So here's your homework for 10.2. We are on page 90. So I'll write that at the top, page 90. So make sure you're at the right page in your book as we're following along. For problem number 1, our first step is distribute that negative. So we're going to write 4m squared minus m plus 2. We copy the first one. Then a negative times a negative is a positive 3m squared. Negative times positive is minus 10m. Negative times positive is minus 4. So we are going to combine our like terms. So I'm going to start with the highest exponent. So I've got 4m squareds and I've got 3m squareds. They're all positive, so I just add them up. 7m squared. Then I'm going to do regular m's. So I've got a negative 1 and I've got 10 negative m's. So minus 1 and minus 10 more is minus 11 altogether. Okay. Then we're going to look and see what's left. We have 2, take away 4. So if I have positive 2 and I'm minus 4, that brings me down into the negatives by 2. You can also think, what do I have more of, positives or negatives? There's way more negatives. I've got 2 extras, right? Twice as many. So negative 2. And then that is what you are going to enter into Canvas. Okay, for problem number 2, make sure that you distribute that negative and start with the highest exponent. So you're going to write your answer in standard form. So we're going to put the r cubes. We're going to put the r squareds. You're going to combine your r's, and then you're just going to write that negative 10 at the very end. Okay, but I know you guys can do that one on your own. So we're going to go ahead and go on to question number 3. Remember, our first step, anytime there's a minus, is that we need to distribute that minus and rewrite it. The first part, I just rewrite how it is. 4d minus 6d third plus 3d squared. Now I'm going to distribute minus 10d to the third minus 7d plus 2. That negative out in front just changes all the signs that follow it. The ones that come before stay how they are, but the ones that go after it all get that negative. Okay, so now we're going to put things together that are alike. So I'm going to start with the d to the third power. So we've got negative 6 and negative 10 makes negative 16 all together. Then I'm going to look at the plain, oh no, just kidding, the d squareds. So I've got only one of those. So I'm just going to copy it down, plus 3d squared. Then I'm going to go to my regular d's. So I've got 4 of them and I've got 7 negatives. So there's more negatives. You'd say I have 4 positives, 7 negatives. 4 of them are going to cancel out, but I still have 3 negatives left over. So I'm going to write negative 3d. And then I'm going to look and say, well, what's left? Just that little plus 2. So I'm just going to write it at the end. Okay. For question 4, that one's a little bit tricky, you guys. So what I would do is I would rewrite. I'm going to help you guys get this one started. Okay. I think you could do it. I think you could figure it out, but I'm just going to help you with the first step on it. Is any pluses, look at all that. I can just write those exactly how they are without the parentheses. We don't need the parentheses when there's pluses. So I'm going to write 4x squared minus 5x plus 6 plus 9x squared minus 2x. But here's the part that we need to change. If there is a negative out in front, you have to distribute that. So minus 11x and then plus 3. So a negative times a positive is a negative times a negative is a positive. Then you guys are going to go through and say, okay, here's a squared, and you're going to put them together. Then you're going to go and say, oh, here's a regular x, here's a regular x, here's a regular x. you're going to put them all together. Then you're going to say, well, here's a constant and here's a constant, and you're going to put them together. Okay, finish it up on your own and then come on over with me to question number 5. Okay, so this one says describe and correct the error. So let's see, they wrote the x squared plus x, that looks good. And then they distribute the negative, so it should be negative 2x. A negative times a negative is a positive. So they forgot to distribute the negative. So write that out and then find the correct answer. Okay, so for the correct answer, we would put the x squared with the negative 2x squared. So that would be negative 1x squared. But then when we add up the positive x and the positive 3x, we would get positive 4x's. So that is the correct answer. They forgot to distribute the negative to everything in the parentheses that followed. Okay, so question number 6, you guys should be able to do, just distribute that. Easy peasy. Okay, question number 7. The cost in dollars of making bee bracelets is represented by this. The cost in dollars of making bee necklaces is represented by this. Write a polynomial that represents how much more it costs to make the necklaces than the bracelets. So what they're saying is we want to do necklaces minus bracelets, because necklaces are bigger than bracelets. So it's going to cost more because they need more beads or chains or whatever it is that you put on necklaces and bracelets these days. If it's my kids, it's embroidery floss, you know, friendship bracelets, whatever. Okay, so what we're going to do is we're going to see, well, how much do necklaces cost? Necklaces cost 8b plus 6 to make, but then I have to subtract how much bracelets cost, and they cost 4 plus 5b to make. Okay, well, I can't leave it like that. I don't know why I wrote all the way on the right side of my paper. You could put it in the middle here where it's actually an appropriate place to put it. And then we're going to subtract. So we need to distribute the negative to both of those. So I'm going to write 8b. I hate it when there's b's and 6's in a problem together. So I'm going to try and make that look like a b plus 6. And then the negative to the 4 is going to be negative 4. And then negative times positive 5b is going to be minus 5b. And so we're going to combine like terms here. So I'm going to start with the b's. So 8b take away 5b would be 3b. And then a positive 6 and a minus 4 would just be a positive 2. So that is my final answer there. So we're just subtracting the necklaces minus the bracelets. Okay, and that is it for 10.2.